Hello everybody, this is Todd Frazee again, and this is the video tutorial for the S60-103 CAD portion for the heating tube. And this is a little bit different part. It's actually a glass test tube that's been cut down in length. So for us to model it, we're going to have to do a little more research than on your typical design. Because somebody else makes the test tube and we don't necessarily have the drawing for that. So let's look at our drawing, and we have a ghost shape of 4 inches in reference. So that's what the part number is when it's purchased, and our task is to cut it down to 2 inches and 150 thousandths. We also have a reference dimension for the diameter. We're not changing the diameter, but we also don't know how thick the wall thickness is. So that's the part we're going to need to go to the vendor and see if we can get more information. So down here in the notes, the material is make from part number, and in the comments it says the part number is from a master car company. So what we're going to do is we're going to highlight that part number, and you should be able to do Control Paste. So Control C would copy it, and we're going to go to McMaster Car's website. It's a great resource. They allow you to download models of all their components pretty much in SolidWorks and a universal CAD system. So I punch in the part number and it comes up with this particular pack of 10, and we're going to look at the product detail for that. Okay, so it doesn't look like this particular one has a model, but we have the diameter and then an inside diameter. So we can use the difference between the diameter, which is nominally 5/8, and subtract 9/16 from it to get the wall thickness. So let's write that down, because we don't want to keep coming back to this. So we've got an outside diameter of 5/8, but our reference drawing has a number there that may be rounded. And then we have an inside diameter of 9/16. Alright, when it comes to a lot of this medical stuff, it's really made in metric, and you measure it, and they've put a fractional equivalent that may not be all that accurate on it for the US market. So those fractional sizes are the closest to the metric, but if you measure the device, it's going to be an even metric number most likely. Okay, so now we can go to SolidWorks and look at our drawing and start modeling. Okay, so again, we're going to go and we're going to create a new part. Make sure it says ANSI here. Your dimensions will look different than mine in inches and pounds. So when you first create the file, set it for ANSI, and I think it stays at that setting for each subsequent part you make. And with this part, I'm going to introduce you to the revolve command. So let's make our planes visible for now. Let's go back to our drawing, and in the front view we're looking at the side of the test tube. So the way we create this shape is we create a profile of half of the part, and then we use a command called revolve, and it allows you to revolve that shape around to make a solid. So there's 2 ways you could approach this. You could revolve just the outside skin of it, and then you can come back and use another command called shell to give it wall thickness, or you model that wall thickness in and revolve it as one piece, and that's what we're going to do in this particular case. So let's go back to SolidWorks, and we're going to use the front plane for our major drawing. Okay, so we're going to draw a sketch. We're going to make it on the front plane. Okay, and we want to anchor to origin somewhere. So I think what I'm going to do is I'm going to start off with a 3-point arc. Start at origin. Pick somewhere out here. So there's the direction I want. And then I'm going to stop because it looks like it was a tangent arc on the test tube. I'm going to stop where it's coincident with the vertical plane. So at this point, all I have to do is give that a radius. Now our specs say that's a 5/8 diameter on the outside, which would make this a 5/16 radius. So let's go ahead and dimension that. And you can put in 5 divided by 16, and that should be the correct radius. So you multiply that out, and it's pretty close to what the reference dimension was. Looks like when it was actually measured, it was slightly under. Then we're going to draw a line from the end of that arc. Hopefully I got the end of that arc. It doesn't quite look right. And I want to snap it to have the horizontal relationship. Then I'm going to come down for the wall thickness and draw a line. Okay, you notice I didn't draw a line for the entire thing. We're going to use the offset entities command for the wall thickness. And we had, if we were to do the math, we've got we're going to take 5 divided by 8, which is 0.625, and we're going to subtract away 9/16, which gives us 0.0625. That is the difference in the outside diameter and the inside diameter, and we're going to divide that by 2, which will give us the wall thickness of approximately a 32nd. Okay, so we're going to go to our offset command, and we're going to select our chain here, and in our number here we're going to put 0.031, which is our 32nd. Okay, so we're going to select the side we want the offset to be on. And I didn't really want this particular thing offset, so we're good there. Okay, drawing that little vertical line was a mistake. Anyway, so we have basically almost a closed loop. We have the 2 parallel lines. We need to connect the endpoints on both ends, and I want that line to have a relationship of vertical. And then we need to connect here. It's not actually connected, it's just touching the plane. Okay, so now it turns gray because we got a fully enclosed loop. Now, this is the shape we're going to revolve around. We still need to constrain it. But for a revolve command, you need a line to revolve around the center line. So we're going to make a center line. And we're going to make it coincident with the plane that's perpendicular. Yeah, it's good practice to have it the full length of your item. Now, this kind of thing can be something that would make your sketch unconstrained if you don't put a length on it. So just for good form, we're going to go ahead and drag this line so that it has relationships with our sketch. So I've aligned it to merge with the end on the one side, and we're going to make it in line vertically by using coincident. So no matter how long this tube becomes, this length of this center line will be the same. All right, let's go through and finish our dimensions. So we've got an overall length from this point to the end of the tube, which was on our drawing 2.15. Okay, so we've got our overall length, we've got a radius set, we still don't have something constrained, so it appears, so let's pull out our model and see what's not constrained. Okay, so in my case, these two lines didn't end up being tangent. So all I should have to do to correct this is make this line and this line tangent, and it should be fully constrained now. So I didn't quite select on that correctly to make it tangent with the auto snaps. All right, let's go to a 3D view. Okay, and down below here you can see our center line we're going to revolve around. We have our shape. Now we can exit sketch. Make sure your sketch is still highlighted. And we're going to go to features, and instead of making extruded boss, we're going to make a revolve boss or base. So we select the command, and it asks you on the first line, what's the axis of revolution? And that's going to be our center line. And it's going to preview what it thinks you want. And right now it's blind. I'm going to just say that's fine, and it's going to go 360 degrees. But if you wanted to do, you know, partial, you could do 270, and it won't revolve all the way around, or 180. So I'm going to put it back on 360 and accept. Alright, so you've pretty much finished that part. If you want to set the materials glass, feel free to. That's what I did in the rendering. I set it to glass and then I made it transparent. So I'll let you do that. I've already showed you how to do that, but there you go. That was a pretty quick one. Quick revolve. Took longer to figure out the wall thickness than it did to actually do the part. But we'll catch you on the next one.